Let's work on a little bit more with trig equations. So trig equations, and I'm going to call this part 3. So let's try to figure out some values and solve some equations. This equation is written this way: sine of x over 2 plus cosine of x over 2 equals 1. Now this one has challenges because it's got half angles and it has different functions. Now you know that sine squared plus cosine squared equals 1, but these are not squares, so they don't work that way at all. So let's look at some identities. The sine of a half angle, I'm going to use theta here. Sine of theta over 2 is plus or minus the square root of 1 minus the cosine of theta all over 2. And the cosine of the half angle theta over 2 is plus or minus the square root of 1 plus the cosine of theta all over 2. So we need to use those. Notice if we use those, everything's going to be in cosine, so that will help a bit. Our answers for x should be between 0 and 2 pi. So we've got to get answers there. Now, I'm going to go ahead and put this in. So the equivalent of sine of x over 2 is plus or minus the square root of 1 minus the cosine of x all over 2. The cosine of x over 2 is plus or minus, so I'll just change the operator there. This is 1 plus the cosine of x all over 2, and this one's 1. In algebra, when you had radicals like this, it was a little easier. It's not ever really easy, but it's a little easier to put one of them on this side and isolate what you can. So I'm going to do that, and I'm going to start squaring both sides. Now when I square both sides, I've got to check my answers and make sure that they work, because this sometimes introduces what are called extraneous solutions, or junk answers that don't really work. So here's what we're going to have. We're going to have plus or minus the square root of 1 minus the cosine of x all over 2, that's this, is equal to, then here we're going to have 1, and this, I'm going to move this over so it actually makes it minus or plus. This is the square root of 1 plus the cosine of x all over 2. So I'm going to square this side. I'm going to square this side. Squaring this side's easy. Squaring plus or minus, you just get plus. Squaring a radical, you just get what's underneath it. So we've got 1 minus cosine of x. Now this side, not as easy, but it's not too bad. We've got to take this as a binomial because it's 1 minus or plus. So first term squared is 1. When you've got a binomial squared, you take 2 times the first times the second. So this is going to be minus or plus, and then 2 times 1 times the square root of 1 plus the cosine of x all over 2. And then here you take the last term squared. So minus squared or plus squared is plus. So we're going to have plus 1 plus the cosine of x all over 2. So that got rid of some of the radicals, but not all. Let's simplify a little bit. This can be joined together with this. So let's subtract 1/2 from both sides. Subtract 1/2 from both sides, that gets rid of that. And let's subtract cosine x over 2. So minus cosine x over 2. So minus cosine x over 2. We've got minus cosine x over 2, minus cosine x over 2. So that's minus 2 cosine x over 2. So there's that. Here we have 1, and then we've got minus or plus. 2 cancels with square root of 2 as a square root of 2. Then we've still got this radical. We've got 1 plus cosine x. So let me subtract 1 from both sides, and we'll square again. So we've got minus cosine x, then I've got to subtract 1. So minus 1 minus cosine x, and this is equal to minus or plus square root of 2 square root of 1 plus cosine x. Now let's square both sides again because we still have a radical. So I'm going to do that. This lets a lot of extraneous solutions in, but we'll check them. So square this one, we get 1. 2 times the first times the second. 2 times negative 1 is negative 2 times negative cosine x, so that's plus 2 cosine x. Then minus cosine x squared is plus cosine squared of x. Minus or plus squared is plus. Square root of 2 squared is 2, and 1 plus cosine x in a radical squared is 1 plus cosine x. Or, if you want to multiply that out, it's 2 plus 2 cosine x. So let's simplify. Let's subtract 2 from both sides. Subtract 2 from both sides, I get negative 1. So subtract 2, negative 1. Subtract 2 cosine x from both sides. Okay, I just kind of use that up. So minus 2 cosine x, so that's 0. And so here is cosine squared. So what do we have? Well, we've got minus 1 plus cosine squared of x equals 0, or cosine squared of x equals 1. If I add 1 to both sides, so take the square root of both sides. When you take the square root, you have got to take plus or minus the square root. So we get cosine of x equals plus or minus 1. Now where does the cosine of x equal plus or minus 1? And here's x, so we actually have dealt with our entire thing, not the half. But x, it happens at 0, it happens at pi. It would happen at 2 pi, but that's not included. So x equals 0 or pi. Those are our two possibilities. Now let's check. And checking with a calculator is kind of nice. So here's what I've got. I've got my calculator put in radians. You'll notice it's in radians. And I've got sine of x over 2 plus cosine of x over 2. Now I've set this up a little differently. I subtracted 1 so that I could say it's equal to 0. Now not only that, I've got my window from a little bit left of the x is 0 point, because x is 0 was one of my answers, and I've got it up to 2 pi. So normally I would just have this, but I just want to see what goes on. So let's graph and see. Now I could zoom trig. Let me do that. Zoom trig so we can see this a little bit better, except it changed my window. So that kind of altered my window a little bit, but here's the deal. Notice it goes through 0, see, because I subtracted 1, it goes through 0 at 0. Let's trace that. So at 0, we get 0. So that was one of the answers. And then here, when I do zoom trig, each one of these little hash marks is pi over 2. So this is 1 pi over 2, 2 pi over 2, so that's pi. So let's check out what happens at pi, trace it at pi, and that's 0. Now notice this is 1.5 pi, this is 2 pi, so there are two solutions, and that's it. Our problem didn't have any extraneous solutions. The two answers are 0 and pi. So that one had quite a bit of algebra involved. Now let's look at a problem that's a little bit less taxing perhaps, but a word problem. Here's a word problem. Now there is a formula that says that the average temperature in Vancouver, British Columbia Vancouver, BC is modeled by this function. So is modeled by this function, f of x. I should call it t for temperature, but f of x is equal to 14 times the sine of pi over 6 times x minus 4 plus 50. So the model is based on months, so X is equal to months, and January implies that X equals 1. So like June is X equals 6 and so forth. Now the question is going to be, when is the temperature equal to, let's see, part A, let's say, is 45 degrees. Part B is 64 degrees. And part C, 36 degrees. Some of these are easy if you know some of the values, and some of them are not as easy. Okay? So what do? Well, we need to put values here. These are temperatures. So this is, even though this is a word problem, it's not too bad, but let me first of all work on part A. So I've got to put 45 in for the temp is equal to 14 times the sine of, let me block this off differently, pi over 6. Notice this is in radians, real numbers, okay, not degrees. Months in degrees wouldn't make much sense, would they? So plus 50. So there we go. Now we've got to solve that. Let's subtract 45 from, well, let's subtract 50 from both sides. That ought to make it a little easier to look at, get sine by itself. So now we've got this, we've got minus 5 is equal to 14 times the sine of pi over 6 times x minus 4, like that. This is gone. If I divide by 14, I now have minus 5 over 14 is equal to the sine of this value, pi over 6 x minus 4. Okay, so minus 5 over 14. Well, I don't know an exact value for that. Whoops, I kind of left you out of that, didn't I? So I don't know an exact value for that. So I've got to do my work a little bit differently. I have got to try to find out where the sign is negative, okay, and put it in. So what do we need to do? Well, first of all, we might want to get a reference angle, okay? So let's do a reference angle. That would mean this is positive, not negative, and then we'll use it. So let's get a reference angle. So reference angle would be arc sine of minus 5 over 14. And that will be equal to pi over 6 times x minus 4. We've got a whole bunch of stuff that it's equal to. So let's take the arc sine of minus 5 over 14. Now that's a calculator question. So let's do that. Arc sine of minus 5 divided by 14. Now, that's not exactly the reference angle, okay? So I'm going to get the negative of the reference angle. I'm literally trying to solve this, I guess, with this one. So let's do that. So I've got minus 0.3652, whatever, okay? So minus 0.365207, blah, 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 is equal to pi over 6 times x minus 4. Let me multiply both sides by 6 over pi. So times 6 over pi. And then I want to add 4. So then add 4. Okay? So multiply by 6 divided by pi. Get that answer. And then add 4. So look what I get. I get 3.3025, blah, blah, blah. Okay. So if that's x, that's one of my answers anyway, isn't it? That is more than 3 months, less than 4 months. So it must be sometime in April. Okay? Now let's take a look. This should have another answer, because wouldn't it go through that sometime in the fall if this is a cyclical deal? So where else is this answer going to be? Okay, well, let's check this out. If we want to get our reference angle, let's come up here and get our reference angle. Now, sine inverse, you might see that. Sine inverse is quadrant 1 or quadrant 4. So if I take the negative of the negative, I get positive. So sine of 5/14 is positive. My reference angle is 0.3652, okay? Approximately 0.3652. So let's put that in another quadrant. Where's the sign negative? Again, well, the sign is negative in quadrant 3, so let's check this out in quadrant 3. So how do I do this? I'm going to take pi. So let's take pi, and I'm going to add 0.3652, and I could put all these digits and I could have used them from the calculator, but let me do this. I've got a little bit of error that I put in there since I literally put the digits. I've got more error than usual, but I've got that, okay? So that's the next thing I'm going to use as a possible angle, because that's a quadrant 3 angle. It'll multiply by 6 over pi, so times 6 divided by pi. And then I'm going to add 4. So plus 4. Notice my other answer is 10.6975 if I round. That is, 10 is October and 11 would be November if I was done with that. So sometime in November, okay? So you have to really kind of work to get that. Now, I've got a couple more answers that we've got to deal with, and these don't need calculators. 64 degrees. Let's talk about 64 degrees. That's part B. If I put 64 is equal to this 14 sine pi over 6 x minus 4 plus 50, subtract 50 from both sides, I get 14 equals 14 sine pi over 6 x minus 4, so forth, okay? Divide by 14, I get 1. So 1 equals the sine of, let me put this in brackets, pi over 6 and then x minus 4. Well, where is the sine equal to 1? In radians. This angle, pi over 6, x minus 4, has got to equal pi over 2. That's where the sine is equal to 1. So if I multiply both sides by 6 over pi, let me do 6 over pi, 6 over pi. That'll cancel that. That'll cancel that and that. This will be 3. So I will have 3 on that side. Let me change sides here. X minus 4 equals 3. So x equals 7. So that would be July. There's only one answer to that one. Now the other possibility, whoops, I kind of left you out of that one. The last question is this one. It is 36 degrees. So C, 36 is equal to 14 sine of pi over 6 x minus 4 plus 50. So if I've got that one, I subtract 50 from both sides. And so minus 50, minus 50. Got minus 14. Here's 14 times the sine of pi over 6, x minus 4. Divide by 14, you get negative 1. So you've got negative 1 is equal to the sine of pi over 6, x minus 4. Well, where's the sine negative 1? It's negative 1 when the angle is 3 pi over 2. So sine of 3 pi over 2. So let's say that 3 pi over 2 is equal to this angle. Now that's from my memory bank of functions. So I need to multiply both sides by 6 over pi like I did with the last problem. 6 over pi. cancel, 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 and this cancels. Okay, 6 times 3 is 18 over 2 is 9. So I get 9 equals x minus 4. So you add 4 to both sides. Now notice this. Add 4 to both sides, you get 13. Okay, 13. What's the 13th month? Well, you can interpret it. Obviously you can, because what I did was I went around the circle and I went around too far because I went past 1 year altogether. It wasn't obvious, but it ended up that way. But what's the 13th month? Well, since this has got to have a cycle of 12 months, then this is going to be January. So same as January has x equals 1, which is January. Now, how could I have done that better? Well, I could have said that this angle has got to have a period of 12, okay? So I would set it up to find out what my x values are for a period of 12. Now, the possibility would have been that x was 1. And I know that doesn't exactly look right, but what would have happened right here that would have made this correct is if I would have said minus pi over 2 instead of 3 pi over 2. So let's look at that. What if I said minus pi over 2 is equal to, this was pi over 6, x minus 4. Okay, so multiply both sides by 6 over pi. So 6 over pi, 6 over pi, like that. I would have ended up here with minus 3. So I've got minus 3. This cancels. Is equal to x minus 4. Add 4 to both sides. 1 equals x. That is January. So that's a little bit better look at that one. I kind of messed up the domain a little bit, although the 13th month is still January. It is a cyclical function. Now let's look at one more thing about this. How do I know the period is 12 months? Well, here is the coefficient of x, and sine functions have periods that are 2 pi over the coefficient of x. So this is 2 pi over 1 times the reciprocal. That's equal to 12. So that's how I knew that the cycle should have been 12 months, plus its temperatures. And they cycle every year, but this is in months. Okay, so there you go.